In October 2017, astronomers gazing through the Pan-STARRS telescope in Hawaii made a discovery that would ripple through the scientific world and beyond. An object, unlike any ever seen before, was racing through our solar system on a hyperbolic path, meaning it wasn't orbiting the sun like our planets and comets. It was simply passing through. They named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. At first glance, it seemed like just another cosmic rock. But as scientists looked closer, this visitor revealed a list of anomalies so baffling, it began to shake the foundations of astrophysics. Oumuamua was elongated, cigar-shaped, roughly 400 meters long but only about 40 meters wide. It had no comet tail, no outgassing, no visible propulsion, and most disturbingly, no heat signature even after passing within 0.25 astronomical units of the Sun, closer than Mercury. Yet, it accelerated as it moved away from the Sun. Not randomly, not chaotically, but with precision. Naturally, astronomers assumed this acceleration was due to comet-like behavior, jets of gas pushing it forward. But they found nothing. No emissions. Not even the faintest puff of vapor. It defied explanation. Then came 2025. With more advanced tools and AI-powered algorithms, scientists revisited the trajectory of Oumuamua using quantum-enhanced optical modeling. This wasn't just refining old data, it was a fresh approach, revealing something astonishing. The object's movement wasn't random. Its acceleration followed a highly precise mathematical pattern that counterbalanced its natural tumbling motion. Every 7.3-hour rotation, it would adjust ever so slightly to stay on course. These micro-adjustments matched theoretical models for advanced light sail propulsion, technology humanity has only begun to consider in labs. Such precision suggested a form of engineering. According to theoretical physicist Michio Kaku, this behavior implied responsive surface geometry, a reflective skin capable of dynamically altering itself to maintain orientation and propulsion from solar radiation. In other words, this wasn't just some interstellar rock. It might have been a probe, equipped with technology far beyond ours. A silent, passive explorer gliding between the stars, powered by light itself. But propulsion wasn't the only anomaly. Using the European Space Agency's Gaia mission data, astronomers traced Oumuamua's trajectory backward to determine where it came from. What they found was even more mysterious. The object appeared to have originated from the local standard of rest, a frame of reference relative to the motion of stars near the Sun. But more specifically, it came from a quiet patch of space devoid of the natural forces needed to eject an object into interstellar velocity. No binary stars, no supernovae, no gravitational disturbances, just a calm, uneventful region where objects should remain in place. This raised a profound possibility. What if Oumuamua didn't escape its home system by accident? What if it was launched, deliberately, into this quiet region to avoid drawing attention? Such a stealth strategy would be ideal for sending something undetected across the galaxy. If someone or something wanted to quietly observe other star systems, this would be the perfect starting point. In March 2025, another wave of revelations emerged. Deep learning systems, trained to detect ultra-subtle patterns, were applied to Oumuamua's brightness data. For years, scientists believed its fluctuating brightness every 7.3 hours indicated a chaotic spin. But the AI discovered something else. The rotations weren't chaotic. They were consistent, deliberate, and even complex. The object wasn't just tumbling. It was scanning. Every 43.8 minutes, small rotational adjustments were observed, possibly exposing different sides of the object to sunlight. These patterns matched spacecraft models used for thermal regulation and energy harvesting. Engineers recognized it immediately. This was exactly how a craft would behave if it was trying to gather power, stay cool, and possibly collect data. The implication: Oumuamua wasn't just moving through our solar system. It was actively managing itself, maintaining its systems, scanning its surroundings, and harvesting solar energy. And yet, it made no sound, no signal. Until now, we assumed that if alien technology ever reached us, it would send a beacon. Hello. Instead, we may have just watched it drift by silently, collecting everything it needed to know. Even more troubling was the object's thermal profile or lack of one. When the Spitzer Space Telescope aimed its infrared sensors at Oumuamua, scientists expected a clear heat signature. After all, anything passing that close to the sun should be glowing with residual heat. But Spitzer found nothing, not a trace. It was as if the object had absorbed sunlight and kept it. This thermal invisibility defies basic physics. Every object in space radiates heat. Even cold comets emit infrared. But not this. The only explanations are unsettling. 1. It's made of a material we've never seen, something with perfect insulation. 2. It uses metamaterials, advanced structures that manipulate radiation in unnatural ways. Or 3. It's equipped with deliberate thermal cloaking, designed to avoid detection. The latter theory is disturbingly close to technologies NASA is experimenting with for stealth spacecraft, only far more advanced. So what was Oumuamua? A rock? A relic? A probe? In 2025, Michio Kaku and Harvard astrophysicist Avi Loeb proposed a bold hypothesis. Oumuamua might be a piece of alien technology, either abandoned or intentionally sent. Not necessarily functional, but still embedded with the fingerprints of intelligence. The shape, behavior, silence, and mystery all point toward design. And there's more. While analyzing its path, scientists noticed that it passed through a region perfectly positioned to observe Earth, the Moon, and other inner planets. For 72 hours, it maintained a near-ideal trajectory to receive Earth-based communications, television, radio, and internet broadcasts. It didn't transmit anything, but it might have been listening, observing, studying. If this was a probe, it might be part of a larger strategy. Some scientists believe advanced civilizations could send out thousands of tiny scouts, quiet, efficient, nearly invisible. Their job? To gather data, avoid detection, and return it home. No contact, no interference, just reconnaissance. If so, Oumuamua's visit could have been one of many. We caught one by chance. How many have we missed? Statistical models based on our observational limits now suggest that one Oumuamua-like object may pass through our inner solar system every single year. But we don't see them. They're too fast, too faint, and often obscured by the sun's glare. That's why the upcoming Vera Rubin Observatory, set to go fully operational by late 2025, is so crucial. Its sweeping sky surveys will dramatically improve our ability to spot these fast-moving visitors, perhaps even in time to send a probe after them. Project Lyra, a concept mission proposed by the Initiative for Interstellar Studies, is already exploring how to intercept future objects like Oumuamua. Using gravity assists from Jupiter and advanced propulsion, we could potentially catch up with one. The physics are daunting but not impossible. But what if the next one doesn't just pass by? What if it slows down? What if it turns toward Earth? Oumuamua may have already transmitted everything it learned about us. Our technologies, our broadcasts, our weaknesses. It may have cataloged our civilization for an intelligence we know nothing about. We've always imagined first contact would be grand. A glowing ship, a message from the stars. But what if it already happened, and we missed it? As we reflect on what Oumuamua was, and what it might mean, we're left with more questions than answers. It wasn't just a rock. It wasn't just a comet. It was something else. Something crafted. Something watching. And if the numbers are right, it won't be the last.